China's Hypersonic Air-to-Air Missile test, a game-changer with over 1,000 kilometers range and Mach 9 speed. Overview. On March 1, 2025, the global military landscape was shaken by reports of China's successful development and testing of a hypersonic air-to-air missile capable of dramatically altering air combat dynamics. This missile is engineered to reach speeds exceeding Mach 5 with an operational range surpassing 1,000 kilometers, effectively challenging advanced military aircraft, particularly the US B-21 Raider stealth bomber. This milestone in military technology represents a significant leap forward in the capabilities of the People's Liberation Army (PLA) and has raised alarms regarding the balance of power in the Indo-Pacific region. Timeline of development and testing. 1. Initial development. The project commenced at the China Airborne Missile Academy, located in Luoyang, Hunan Province. Researchers and engineers embarked on a mission to create a hypersonic missile that could outpace existing air defense systems and engage high-value aerial targets. 2. Rigorous testing phases. In preparation for operational deployment, the missile underwent extensive heat resistance testing in an advanced arc-heated wind tunnel. This facility is capable of simulating conditions akin to those faced by spacecraft during re-entry, exposing missile prototypes to extreme temperatures exceeding 1,200 degrees Celsius. Such testing is essential to ensure the missile's structural integrity and performance at hypersonic speeds of up to Mach 9. 3. Final test announcement. On January 19, 2025, China publicly confirmed the successful completion of its final tests. This announcement coincided with the increasing scrutiny of U.S. military capabilities, particularly as the B-21 Raider transitioned into its flight testing phase, highlighting the urgency of countering perceived threats from advanced U.S. aerial assets. 4. Strategic implications. Analysts express concerns that the introduction of hypersonic air-to-air missiles could fundamentally alter aerial warfare protocols. The ability to strike targets at extreme ranges and speeds presents new challenges for air defense systems, which may struggle to intercept such fast-moving threats. The implications for U.S. military strategy and air superiority are profound, necessitating a re-evaluation of existing defense measures. Key aspects of the missile technology. Advanced hypersonic capabilities. The missile's ability to travel at speeds exceeding Mach 5 represents a technological leap that could redefine engagement distances and response times in air combat. Traditional missiles typically have a range of several hundred kilometers, while this hypersonic missile can engage targets over 1,000 kilometers away, significantly reducing the reaction time for adversaries. Targeting high-value assets. The primary design goal is to counter advanced stealth aircraft like the US B-21 Raider, which could potentially be rendered vulnerable against such fast-moving threats. The missile is intended to penetrate air defenses and engage high-value aerial targets, thereby enhancing China's strategic deterrent capabilities. Complex testing requirements. The development of hypersonic systems involves significant engineering challenges and high costs. The arc-heated wind tunnel utilized for testing, which can operate continuously for extended periods, represents a critical investment in ensuring the missile's viability under operational conditions. Reactions and analysis. The introduction of China's hypersonic air-to-air missile has sparked a mix of alarm and intrigue among military analysts and policymakers around the world. Various sources have highlighted a few common themes regarding its implications. Technological superiority. There is a consensus that China's advancements in hypersonic technology signify a major shift in military capabilities. The potential to engage targets at unprecedented ranges and speeds poses a formidable challenge to existing air defense systems, particularly those employed by the U.S. and its allies. Impact on U.S. military strategy. The B-21 Raider, an advanced stealth bomber designed for high-stakes missions, may require re-evaluation of its operational protocols in light of this new threat. Analysts warned that the effectiveness of stealth technology may be diminished against hypersonic missiles, necessitating new countermeasures and strategies. Geopolitical tensions. As the balance of power in the Indo-Pacific region continues to evolve, the introduction of such capabilities by China is likely to exacerbate existing tensions. U.S. military planners will need to consider the implications of China's advancements on regional security dynamics, particularly in contested areas such as the South China Sea. Conclusion: China's successful testing of a hypersonic air-to-air missile marks a critical juncture in military technology development. With capabilities that could redefine air combat, this missile poses a significant challenge to established military powers, particularly the United States. As nations grapple with the implications of hypersonic weapons, the landscape of modern warfare is set to change, emphasizing the need for advanced defensive measures and strategic adaptations to maintain aerial superiority. The continuing evolution of hypersonic technology will undoubtedly influence military planning and international relations in the years to come. The recent development and testing of China's hypersonic air-to-air missile has raised significant concerns among military analysts globally, particularly regarding its implications for U.S. air dominance. Below are the counterintuitive aspects identified within the content. 1. Misconception about speed and stealth. While the US B-21 Raider is touted as a highly advanced stealth bomber, the introduction of hypersonic missiles could negate some of its stealth advantages. The assumption that stealth alone can ensure safety in modern warfare is challenged by the fact that hypersonic missiles traveling at speeds over Mach 5 and potentially reaching Mach 9 can engage targets much faster than the B-21 can react or evade. This situation suggests that speed may increasingly outweigh stealth in air combat scenarios, reversing traditional military wisdom that prioritized stealth technology. 2. Cost of advanced technology. The substantial costs associated with developing and testing hypersonic systems may lead to a paradox where advanced military capabilities are not exclusive to wealthier nations. While it is commonly assumed that only technologically advanced nations can afford such innovations, China's investment in hypersonic technology demonstrates that rapid advancements can come from countries with different economic structures and priorities. This could lead to a reassessment of the global military landscape, where emerging economies can challenge traditionally dominant military powers through innovation. 3. Impact on traditional defense systems. The expectation that existing air defense systems can effectively counter hypersonic threats may be overly optimistic. The speed and trajectory of hypersonic missiles significantly reduce the time available for interception. As a result, traditional defense strategies which rely on conventional missile detection and interception may prove inadequate. This situation raises questions about the effectiveness of current military investments in air defense technology that are based on historical norms rather than adapting to the new realities of hypersonic warfare. 4. Global arms race implications. The narrative around hypersonic missile development often emphasizes a race between superpowers. However, the existence of such technologies could also spur smaller nations to invest in similar capabilities. The assumption that only major nations like the US, China, and Russia will lead in hypersonic technology overlooks the potential for a broader proliferation of such weapons. This could lead to a more complex geopolitical landscape where numerous countries possess advanced hypersonic capabilities, fundamentally altering deterrence strategies and international relations. 5. Scientific collaboration versus secrecy. The development of China's hypersonic air-to-air missile highlights a tension between secretive military advancements and the scientific community's role in technological verification. The rigorous peer-reviewed processes mentioned in the sources serve to validate the missile's existence and capabilities, suggesting that while military projects may be classified, the underlying scientific principles often require collaboration and transparency. This duality challenges the narrative that military advancements are solely the product of government secrecy, emphasizing the importance of scientific scrutiny in validating military claims. These counterintuitive insights reveal that the implications of China's hypersonic missile advancements extend beyond immediate military strategy, challenging long-held assumptions about stealth defense capabilities, economic power, and the nature of global military dynamics. China's recent development and testing of a hypersonic air-to-air missile with an operational range exceeding 1,000 kilometers and speeds of up to Mach 9 is a significant milestone in military technology. Here are critical elements of the report that many might overlook along with explanations of their significance. 1. Testing methodology. The missile's testing involved rigorous heat resistance trials in an arc-heated wind tunnel which can mimic the extreme conditions faced during high-speed flight. This testing is particularly noteworthy because it demonstrates China's capacity to conduct advanced scientific experiments typically reserved for space missions. The implications of this capability extend beyond missile development, suggesting that China is enhancing its overall technological prowess, which could lead to breakthroughs in various fields, including aerospace and materials science. 2. Strategic targeting. While the report emphasizes the missile's threat to the US B-21 Raider, it also highlights that the missile is designed to engage high-value aerial assets. This point is significant because it underscores a shift in military strategy where hypersonic missiles may be used not just against bombers but also against reconnaissance and command and control aircraft like AWACS. The ability to target these assets effectively could disrupt U.S. military operations significantly, as they are critical for situational awareness and battlefield management. 3. Economic and engineering challenges. The development of hypersonic weapons entails substantial economic investment and sophisticated engineering which few nations, including the U.S. and Russia, have undertaken. The mention of the high operating costs associated with the wind tunnel testing indicates that China is willing to allocate significant resources toward maintaining its competitive edge in military technology. This commitment might encourage other nations to reconsider their military budgets and research priorities, potentially leading to a global arms race in hypersonic technology. 4. Peer review and scientific validation. The report mentions that details of the missile's performance evaluations were published in a peer-reviewed paper. This aspect is often overlooked but is essential because it lends credibility to China's claims regarding the missile's capabilities. Peer-reviewed research indicates rigorous scientific scrutiny, which can help legitimize China's advancements and possibly influence international perceptions of its military capabilities. It also highlights that China is increasingly integrating a culture of scientific validation into its military technology development. 5. Impact on U.S. military strategy. The report suggests that the introduction of hypersonic air-to-air missiles could fundamentally alter the balance of power in the Indo-Pacific region. The potential for rapid engagement times and long-range strikes means that U.S. air defense systems may need to evolve significantly to counter these threats. This change could lead to a re-evaluation of U.S. military strategies, including investments in new technologies or altered operational doctrines focused on countering hypersonic threats. 6. Geopolitical ramifications. The missile's capabilities are likely to influence not only U.S.-China relations but also the dynamics of other regional powers in the Indo-Pacific. Countries like Japan, South Korea, and Australia may feel pressured to enhance their own defense systems or seek closer military ties with the U.S. to mitigate the perceived threat from China's advancing military technologies. The geopolitical landscape could shift, leading to new alliances or exacerbating existing tensions. 7. Public perception and response. The report also reflects how public discourse around military advancements can shape perceptions of national security. Comments from various sources indicate a significant concern regarding U.S. military dominance being challenged by China's advancements. This sentiment may influence public support for defense spending and military readiness in the U.S., and it could lead to increased calls for transparency regarding military capabilities. 8. Technological leadership. The successful test of this missile positions China as a leader in hypersonic technology, potentially shifting the narrative from a follower to a front-runner in military innovation. This change could have far-reaching effects on global military dynamics as nations look to align themselves with technological leaders or invest in rival capabilities to maintain parity. In conclusion, the development of China's hypersonic air-to-air missile is more than just a technological advancement. it represents a significant shift in military strategy, global power dynamics, and geopolitical relationships. These overlooked aspects underscore the complexity of the situation and the potential repercussions that extend far beyond military capabilities alone. Understanding these dimensions is critical for policymakers, military strategists, and analysts as they navigate an evolving landscape of international security. 1. Technological advancements in hypersonic weapons. The development of China's Hypersonic Air-to-Air Missile represents a groundbreaking leap in military technology. Capable of reaching speeds exceeding Mach 5 and with an operational range of over 1,000 kilometers. This missile fundamentally alters the air combat landscape. The missile's remarkable speed allows it to engage targets much faster than traditional missiles, posing significant challenges for air defense systems. The technological sophistication required for such advancements, including rigorous heat resistance testing and state-of-the-art facilities, illustrates the complexities involved in hypersonic weapon development. These advancements not only enhance China's military capabilities but also set a new standard for future air-launched weapons. 2. Strategic implications for U.S. military assets. The hypersonic missile poses a direct threat to advanced U.S. military assets, particularly the B-21 Raider stealth bomber. Analysts suggest that the introduction of such capabilities could undermine the effectiveness of stealth technology, as the missile's speed and range enable it to potentially engage U.S. aircraft before they can complete their missions or evade detection. This shift in the balance of power in the Indo-Pacific region raises concerns regarding U.S. military strategy and deterrence, as reliance on traditional air superiority may become increasingly untenable against such fast-moving threats. The missile's design specifically targets high-value aerial assets, indicating a strategic focus on countering U.S. air dominance. 3. Testing and development challenges. The rigorous testing processes required for the Hypersonic Air-to-Air Missile highlight the significant engineering and economic challenges faced by nations developing such advanced weaponry. The use of an arc-heated wind tunnel for heat resistance testing, which simulates conditions encountered during high-speed flight, underscores the complexity and cost associated with ensuring the missile's operational reliability. The technical hurdles involved in developing hypersonic systems demand substantial investment and ingenuity, which few nations can currently afford. As such, the successful development and testing of China's missile reflect not just military aspirations but also the country's commitment to becoming a leader in cutting-edge military technology. For impact on global military dynamics, China's advancements in hypersonic missile technology could lead to a significant shift in global military dynamics, particularly in the Indo-Pacific region. The introduction of these missiles may compel the U.S. and its allies to reconsider their defense strategies and investment priorities in air defense systems. The potential for hypersonic missiles to change the rules of engagement emphasizes the need for nations to adapt to a new era of warfare where speed and range are critical factors. This technological arms race could further escalate tensions between major powers, leading to an environment of uncertainty and conflict. As countries vie for dominance in hypersonic capabilities, the geopolitical landscape may become increasingly complex, necessitating new forms of diplomacy and strategic partnerships. 1. The V-2 rocket. Germany. World War II. The V-2 rocket, developed by Nazi Germany during World War II, is often regarded as the world's first long-range guided ballistic missile. It was capable of reaching altitudes of over 100 kilometers and could travel at speeds exceeding Mach 5. The V-2's development represented a significant technological leap in missile technology and was used to target cities in Allied territories, most notably London. Its introduction changed the dynamics of warfare, showcasing the potential of rocket technology for military applications and leading to the post-war space race and missile development programs in both the United States and the Soviet Union. 2. The Soviet Ir-36 Satan missile. Cold War era. The Ir-36, commonly referred to by NATO as the SS-18 Satan, was a Soviet intercontinental ballistic missile developed during the Cold War, capable of carrying multiple warheads and striking targets over 10,000 kilometers away. The R-36 was a game-changer in the nuclear arms race. Its advanced range and payload capacity forced the United States to rethink its strategic defense systems and contributed to the doctrine of mutually assured destruction (MAD). The R-30's development highlighted the significant shifts in military capabilities and the strategic balance during the Cold War. 3. The U.S. Tomahawk Cruise Missile. Gulf War 1991. The Tomahawk cruise missile developed by the United States gained fame during the Gulf War for its precision strike capabilities. With a range of over 1,600 kilometers, the Tomahawk can be launched from various platforms including surface ships and submarines, and can carry both conventional and nuclear warheads. Its ability to accurately hit high-value targets with minimal collateral damage revolutionized modern warfare and set a precedent for future military engagements. The successful deployment of the Tomahawk demonstrated the effectiveness of precision-guided munitions and influenced military strategies in subsequent conflicts. The recent advancements in China's hypersonic air-to-air missile technology, particularly its ability to reach speeds exceeding Mach 9 and ranges over 1,000 kilometers, herald a significant shift in military capabilities and air combat dynamics. As the global military landscape continues to evolve, several future outlooks and predictions can be drawn from this development. 1. Shift in military balance. China's hypersonic missile capabilities are likely to challenge the long-standing military dominance of the United States, especially in the Indo-Pacific region. The ability to engage high-value targets like the US B-21 Raider from a distance fundamentally alters the calculus of air combat. As these missiles can reach targets much faster than traditional systems, they reduce the reaction time for U.S. forces, potentially leading to a shift in power dynamics where traditional air superiority may no longer guarantee success. 2. Increased arms race. The introduction of such advanced weaponry will likely trigger an accelerated arms race not only between the U.S. and China but also among other nations. Countries may feel compelled to invest in their own hypersonic technologies or advanced countermeasures to mitigate the threat posed by such missiles. This could lead to a proliferation of hypersonic weaponry and a re-evaluation of existing defense strategies globally. 3. Evolution of air defense systems. As hypersonic missiles become more prevalent, air defense systems will need to adapt accordingly. Current systems may struggle to intercept missiles traveling at such high speeds. This will push defense contractors and military strategists to innovate and develop new technologies, including advanced radar systems, kinetic interceptors, and electronic warfare capabilities to counter hypersonic threats effectively. 4. New tactical approaches. Military strategies will increasingly focus on the integration of hypersonic capabilities into broader operational frameworks. This could involve the development of tactics that leverage the speed and range of these missiles to conduct preemptive strikes or to disrupt enemy operations before they can respond. Joint operations involving air, land, and naval forces may also be redefined to account for the new threat landscape. 5. Diplomatic implications. The advent of hypersonic missile technology may strain diplomatic relations, particularly between the U.S. and China, as both nations navigate this new reality. There may be increased tensions and a potential for miscalculation during military interactions. Diplomatic efforts will be crucial in establishing frameworks for arms control or confidence-building measures to prevent escalation into conflict. 6. Focus on research and development. The competition in hypersonic technology will catalyze investments in research and development across various nations. This focus will not only enhance military capabilities but may also spur advancements in related fields such as materials science, propulsion systems, and aerospace engineering. The technology developed could have civilian applications, leading to innovations in commercial aviation and space exploration. 7. Global security landscape. The global security environment is likely to become more volatile as nations respond to the emerging threats posed by hypersonic weapons. Regional conflicts may escalate as countries seek to bolster their military capabilities in response to perceived threats. The balance of power in regions like the South China Sea may shift, influencing geopolitical alignments and alliances. 8. Public perception and policy change. As hypersonic missile technology becomes more prominent in military discourse, public perception of national security will likely change. Citizens may demand greater accountability and transparency from their governments regarding military spending and the implications of such advanced weaponry. This could lead to policy shifts, including calls for arms control agreements or increased oversight of military technologies. Conclusion: China's hypersonic air-to-air missile represents a significant advancement in military technology, one that is poised to reshape air combat and influence global military strategies. The future outlook indicates a complex interplay between military innovation, geopolitical maneuvering, and diplomatic efforts. As nations adapt to these challenges, the pursuit of balance between deterrence and diplomacy will be crucial in navigating the uncertain waters of modern warfare. The coming years will likely witness an escalation in technological competition and strategic planning, fundamentally altering the landscape of international relations and military engagement.